Welcome everyone to a new tutorial in Erdas Imagine, and in this session I will show you how to recalculate your raster data to get some binary raster data, and also some, I may call it ISO raster data, because we will use a conditional statement to choose whether a pixel is in between a range or not, and we will create out of this some new data. And we will do that on height data. I've downloaded that from landcover.org. This is the SRTM3 dataset, which has a ground resolution of about 90 meters. And as you can see here, it's already prepared. So I've calculated statistics, and what is quite important is that you have to set the no data value, because just by looking in this area here, so you maybe also see the blackish spots here, this pixel has a quite distinct value, because the range of the whole data set is 16-bit, signed 16-bit, so this pixel here has a value of minus 32,700 something, and this is not indicating the real height, of course not, but it is a value of a missing value. So normally, if you have a data set, you have a very distinct value for the not a number values or the missing values, like NaN or minus 9,999. And in this case, it's the lowest possible number in the data set. So this is minus 32,000. And to correct this in your data, you have to set the utility layer info, and first of all add it, and then set no data value. So you have to paste in the value of the no data value here and press OK. After that, the scene would probably be as grayish as in the first part, but then you can also calculate the histogram, as you can see here. And a very important thing on that is that you have to ignore the value minus 32,786, and then the histogram is calculated, and as you can see here, we have just a few numbers of pixels here in the lower range of height. Then there is a big bulk around 1,600, 1,900 meters and 1,300 meters, and just a few pixels regarding this maximum height over here. And yeah, that's for the first part. So if you want to have a really good picture on your data, and so you can see the differences between heights, as you can see here, this is a really good incised canyon from the Orkhon River in central Mongolia. You probably have to arrange the view using the contrast, and therefore the general contrast. So you can choose between standard deviations and also like this minimum maximum slice here, or the histogram equalization, and we'll leave it like that. So this is histogram equalized, so nothing to see at all, and we will just rearrange that. So standard deviation stretch, this looks quite good. And yeah, as you can see here, so you have some feeling about your data set, and also about your height, but you cannot differentiate between where the hell is the ridge. So it should be somewhere here, but you're not really sure. So therefore we will use another tool in Erdas Imagine to create a so-called shaded relief, and therefore just go on Interpreter, Topographic Analysis, Shaded Relief, and we have to input the source data. So this is all file based. This is the SRTM, so the height values, and we have to change the output. So this is a shaded relief .img. Okay, and we will use elevation units is meters, that's for sure. Then DM scale will be fine as well, and this is the important thing here. So you have a solar azimuth. That means that you have some kind technical light above the sky, in the sky, which is illuminating the surface, and you can change the values of this artificial light regarding each pixel. So this is now in the, I think it's the southwestern part, and the elevation is 45 degrees above the ground. Just one more coffee, it's really early today. So we will leave that as it is, and it's now calculating the shaded relief. And so we will have a second view, and let's have a look on this. How does it look like? And what is for sure, you have to oh no, not vector, it's raster. You have to be careful in using this image. So as you can see here, there's a lot of gray and white, and we will just link these both images. So link, geographical linking over here, and not full scale, please, a little bit smaller to get these both at hand. And as you can see here, so you have these whitish box over, and we will just change it to over there and zoom a little bit in. And as you can see, you have a distinction between northern exposed slopes, southern exposed slopes, and so the intensity, or the gray value, or the digital number in here, is the amount of light which is reflected towards the artificial light. So if you have a slope that is looking into southwestern direction in an angle of 45 degrees, the value has probably a value of 1. And if you have the other side, you have a value of nearly 0. So this slope is probably looking into southwestern direction, and this is a valley, as you can see here, and there's the next ridge over here. So this is probably the ridge, but you will have some problems if the ridge isn't looking into the direction of the artificial light. So therefore we have to calculate another raster, which is called the aspect, and the aspect is only the the direction of the vector of the slope. And now we have two information. So first hand slope, and the second is aspect. So maybe we should calculate the slope at first hand. So therefore interpreter, topographic analysis, and slope. And you have to keep in mind that this calculation of slope isn't the calculation of slope, it is a calculation of slope, because there are different possibilities of calculate this, and you have to check the literature to get an overview which calculation is used by Erdas Imagine, and maybe by ArcGIS or SagaGIS or GrassGIS or whatever. So we will concentrate on the slope calculation, and we will use degrees as indicating the slope. So it's also put so the unit is also correct here, so we will use degrees, and now just calculate that. Open another view, just keep in mind that image, and open the slope in degrees. Fit image to window, so it's all whitish. What's happening here? I'm not really sure about that. Just a second try, maybe. Nope. Nope. Here we go. Topo 0. Maybe I have chosen not the SRTM. And we will calculate the slope. Okay. Yeah, please delete it. And use slope in degrees. And once again, SRTM, slope in degrees, everything looks fine. I hope it's calculating well. Let's have a look in the new viewer. Yeah, there we go. So probably I have done something wrong in the first part. I haven't checked quite carefully. And as you can see here, there are some whitish and blackish dots or pixels, and you can see the valley bottoms and the ridges over here. So this is a valley, there's a ridge coming here, this is another valley, it's not a ridge, because valleys and ridges probably have 0 degrees in slope. And we just concentrate on this image in the left, and we will unlink or link this with that. And as you can see, this over here, there are some features you see in here which are not so good to see over here. So there are some valley bottoms and ridges coming out. Here's a valley bottom, there's a corresponding ridge, and especially over here there's not that good to see where's the ridge going. So this is slope, and as you can see in the inquire cursor function, you will have the slope over here. So this is 5 degrees, up here 22 degrees in slope, 0 degrees slope. And this is quite useful if you are interested in, okay, how is my area maybe affected by erosional processes or some kind of relief energy, and also soil erosion, because normally you probably will use Osel or Russell, and therefore you will surely need the slope. Keeping that in mind, we have to concentrate on the third one. This is aspect. Aspect, as you can see here in the interpreter, topographic analysis again, aspect is the direction of the slope. So where's the slope heading to? And we will use as well the SOTM data, and we will use another, so this is aspect, aspect.img, and we will leave it in continuous mode, because you will distinguish between north, northwestern, northeastern, and so on, and therefore we will just have degrees. And it is starting by 0 degrees representing north, going over 90 degrees representing east, 180 degrees representing south, 270 for the west, and 360 on 0 again for the north. And this is quite interesting, because if you look on the aspect image you will have here, so all the slopes which are white or black are facing the same direction, because the value or the area or the direction is quite the same. As you can see here, we will just check it on this example here. So go into detail here, use the inquire cursor, and as you can see here, this pixel is looking into 359 degrees, which is probably northwestern, something like that. And if you're looking over here, this is representing 4 degrees, so northeastern. And of course it is the same direction, but it looks different if you're just concentrating on the so-called colors, maybe, or the grayish tones. Probably these all gray values are representing southern directions, white and black as representing northern directions. So you can distinguish between whether slope is looking into north, which is quite important in Mongolia, because you will find a lot of trees on north-facing slopes, because the hydrological behavior of the soil is different from the southern slopes. And also, if you're interested in hang slides or something like that, you will probably need the aspect of the slope to get an idea about the behavior of slopes regarding there some precipitation input. Cannot get enough from that coffee. So this is the first part. So we will have these image is, and we will now concentrate on whether the image or whether we can see a special value in the image. So we will use another viewer and also a modeler. And you probably got to know the change detection. I'm not really sure about that, but you can use a raster data, then a process, and a second raster. And you have to connect these elements together, and we will use as an input raster our slope raster, because we are interested in areas where the slope is beyond 25 degrees, because maybe this is probably an area which is affected by erosional processes or hang slides, and we will use this slope as an input. And as you can see here, you have a lot of functions for your usage, and we will now go with the conditional function, especially the conditional statement. And as you can see, differentiate between a pixel goes along with the test, and if you pass the test, it will be filled with an argument 1, and if it's passing another test, it will be filled by a second argument. So you have to be sure which or how does your test look like. So we will use the slope, and we will have a look whether slope is less or equals 1025. So this is the possible values in the slope, so 25 degrees, and if it's passing this test, it will get a 0. Or maybe we are not only interested in whether a slope is minus or less than 25 inclined or more than 25 degrees, but we will maybe interested in severely infected slopes and more or less infected slopes. So we will use another test. So this is less or equals 15 degrees, and we will have a look on whether a slope is bigger than 15 and less or equals 30. And so this is the second test. So if it probably fails this test, you can Erdas will have a look in this statement and tries whether the pixel is passing this test. And if it's passing this test, it will get the value of 1. You can also see the 3 dots in here, so this means that we can input another statement or another test, and we will test whether the slope value is bigger than 30 degrees. And if it's passing this test, it will get the value of 2. So this is a statement, so once again read it out. If the slope is less or the same as 15 degrees or equals 15 degrees, then the pixel gets the value 0. If it's between 15 degrees and 30 degrees, then it will get the value of 1. If it's beyond 30 degrees inclined, then it will get the value of 2. So this is our statement in first hand, and we will choose another raster, which is the output raster, and therefore we will get some kind of classified slope 3 classes. So there we go, and you have to think about whether you will need the unsigned 8-bit information, or you probably can go along with the unsigned 2-bit, because the only possible values in our output rasters are 0, 1, and 2. Just 3 numbers and not 256 or something like that. So we will use unsigned second 2-bit, and this is probably a thematic raster, so you don't have continuous data, as you can see here. So this is a thematic raster. Once again, we will go along and try to calculate that, and you will probably see that more than once, because you have to look on the statement again. So just check pass arrow at or near this construct or this symbol, so that this is less or equals. So we have to check again the conditional statement. So there's one, there's another, and this is fine. I'm not really sure what it is, what's the problem here. I don't think that it is the one over here, so this is fine as well. So you can check with the with this as well. So the statement is probably looking like that, but that should be fine, I think. So it's again less or equal. So there's the problem. So we have to fill in another. So the first test was slope bigger than 15 and less than 30, but you have to once again fill in the raster data which has to be tested. So slope less than 30. This is, I think, I hope. Let's go on. And so it's already calculated. Once again, we will open the classified slope. As you can see here, we are now having 3 possible values, and especially in this area you will see that there are areas with normally incised slopes, probably values of about 10, 5, 8 or something percent, and especially less than 15%, and so this is a value of 0. And you will also find values of 2. These are the areas representing slopes beyond 30 degrees, and also this grayish color is the value of 1. And this is the first part, so you can use this, and you can also make some binary additions. So you will concentrate on this. So you have a binary raster like that, and you will create maybe just a binary raster with values or with pixels that are heading towards northern slopes or northern directions. So they are maybe not that influenced by erosional processes, and more the southern slopes are. And due to this, you can probably see more patterns in your data, and you can just scale down your information, because maybe you are not interested whether a slope is incised 15.4 degrees or 16.7 degrees, but you're more interested whether a slope is more or less than 25 degrees. And this is a good example how to use or how to get this information about a raster in Erdas Imagine. Thank you for watching.